Hello, everybody. So today we're going to review for the Chapter 4 test. We are on page 181 of the third grade textbook. So Mrs. Ruiz sorted spools of thread into 4 boxes. Each box holds 5 spools. How many spools of thread does Mrs. Ruiz have? So we're asked to find how many spools of thread she has. We know she has 4 boxes and she has 5 spools in each box. So draw circles to model the problem, and then solve. So the boxes here represent her 4 boxes. So we need to put 5 spools in each box. Okay, and so we have 5, 10, 15, 20. Okay. Mrs. Ruiz has 20 spools of thread. For numbers 2a through 2d, select true or false for each multiplication sentence. Okay, so is 2 times 8 16? Well, 2 times 8 is the same as saying 8 plus 8, and 8 plus 8 is 16. So this is a true statement. 5 times 8 equals 40. Well, we can skip forward by 5s 8 times. 5, 10, 15, 20, 25, 30, 35, 40. Yes. 6 times 8, 56. Well, if 5 times 8 was 40, 6 times 8 means there's just one more 8. 40 plus 8 is not 56. 40 plus 8 is 48. So that's false. Is 8 times 8 64? Well, again, if 8 times 5 is 40, 8 times 8 is 3 more 8s. 8 times 3 is 24. 40 and 24 is 64. 8 times 8 is 64. Bella is planning to write in a journal. Some pages will have 1 journal entry on them, and other pages will have 2 journal entries on them. If Bella wants to make 10 entries, how many different ways can she write them in her journal? So, how many different ways can she write them in a journal if she wants to make 10 entries? Okay, so important information we have. We know some pages will have 1 journal entry. Others will have 2 journal entries. So let's make a table to represent this information. So we can write 2 entries, 1 entry, and it has to have a total of 10. All right. So I can't have 5 pages of 2 because it says some pages will have 1 and others will have 2. So the most pages I can have with 2 entries would be 4. If 4 times 2 is 8, how many more can I put? How many pages can I put for 1 entry? I can put 2 pages of 1. Okay, 4 times 2 is 8, plus the 2 pages of 1 gives me a total of 10. All right, how about 3 pages of 2? 3 pages with 2 entries would be 6 entries. That leaves me 4 more entries. All right, how about 2 pages with 2? 2 pages with 2 would be 4 entries. 4 plus what is 10? 6. Starting to notice a pattern, right? 2, 4, 6, 4, 3, 2. So if we have one page with 2 entries, that's only 2 entries. So 2 plus what is 10? 8. Okay. And then I can't have no pages with 2 because, again, it says they will have one journal entry on them and others will have 2. So these are the possibilities. So there's 4 ways. All right, number 4. There are 7 days in 1 week. How many days are there in 4 weeks? Well, there's numerous ways we can do this. We've learned multiple strategies for multiplying. I'm going to do a couple of them. The easiest one is just to know what 4 times 7 is. 4 weeks, and there's 7 days in a week. 4 times 7. That's the easiest. I can draw a picture. And each box represents 1 week. And there's 7 days in each week. So 7 after the first week. 7 and 7 is 14. 14 plus 7 is 21. 21 plus 7 is 28. I could do 7 times 2 times 2. In other words, 7 times 4 is the same as 7 times 2 doubled. 7 times 2 is 14. And 14 plus 14 is 28. Okay. I could do 4 times 3 plus 4 times 4. Use the distributive property. But anyway, 28 days. All right. Circle groups to show 3 times 2 times 3. Okay, remember, this means I have 3 sets of 2 times 3. 3 sets of 2 times 3. Well, how much is 2 times 3? 2 times 3, that's 3 plus 3. That's 6. So 3 sets of 6. Okay, well, 2 rows of 3. Yeah, that makes sense. 2 rows of 3. 2 rows of 3. So I have 3 sets of 2 times 3. Number 6. Dale keeps all of his pairs of shoes in his closet. Select the number of shoes that Dale could have in his closet. Mark all that apply. Well, pairs. Shoes come in pairs of 2, right? All right, so can you have an odd number? No, we can't have odd. So let's eliminate those right now. Select the number of shoes he could have in his closet. Could he have 4 shoes? Sure. That would be 2 pairs. Could he have 6 shoes? Yes. That's 3 pairs. Could he have 8 shoes? Yeah, that's 4 pairs. But he can't have 3 shoes. That would be a pair and a half. He doesn't have 3 feet. All right. Number 7. Lisa completed the table to describe the product of a mystery 1-digit factor and each number. So she multiplied and she got an even answer when she multiplied by 1. And then she multiplied again by 2 and she got an even answer. Then she multiplied by 3 and got an even answer. Then she multiplied by 4 and got an even answer. And then she multiplied by 5 and got an even answer. What are all the possible numbers she could have been multiplying by? Well, we know that any number times 2 is an even answer. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So 2 is definitely a possibility. How about 3? Let's just try it. 3 times 1 is 3. Oh, that's not even, is it? Okay, so no. How about 4? 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Yeah, 4 works. 5 times 1 is... Okay, so I'm thinking that you can't multiply by any odds. Let's try 7 real quick. 7 times 1, that's odd. Okay, so yeah, you can't. So 6 will work. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. Okay, so that's working. So basically, if the factor I'm multiplying these by is even, my answer has to be even. All right, so 2, 4, 6, and 8. Explain how you know that you have all selected all the correct answers. 2 times 1 is 2. 4 times 1 is 4. 6 times 1 is 6. 8 times 1 is 8. This shows that even times odd equals an even product. And 2, 4, 6, 8 are the only even one-digit factors. Number 8. Kate drew 7 octagons. An octagon has 8 sides. How many sides did Kate draw? Okay, so 7 octagons, 8 sides. So that problem is telling me 7 times 8. I have 7 sets of 8. Well, again, the easiest way to know that is just know that what 7 times 8 is. But if we weren't sure what 7 times 8 is, can I make it into something a little easier to do? Well, I could rewrite 7 times 8 as 7 times 5 plus 7 times 3. Okay, so I can use the distributive property to make that easier. 7 times 5 is 35. And 7 plus times 3, well, I know 7 times 2 is 14. Add 7 more, that's 21. What is 35 plus 21? 56. So 7 times 8 is 56. Jose buys 6 bags of flour. Each bag weighs 5 pounds. How many pounds of flour did Jose buy? 6 bags of flour, 5 pounds each. How many pounds did he buy? 6 times 5. Okay, well, we don't need to do any real special drawing for this one. We should be able to count. We should just know what 6 times 5 is. Okay, how much is 6 sets of 5? 5, 10, 15, 20, 25, 30. 30 pounds. Number 10, break apart the array to show 8 times 6 is the same as 4 times 6 plus 4 times 6. So there's 2, 4, 6 squares in a row. So there's my 6's. And now I need 4 rows of 6. 1, 2, 3, 4. 1, 2, 3, 4. So, okay, right in half. Circle the symbol that makes the multiplication sentence true. 9 times 6. 9 times 6. Well, can we use the associative property to rewrite this one? Sure. We can group 3 times 3 so it looks like that. Okay, I didn't change the problem. I didn't change the numbers. All I did was regrouped the factors. 3 times 3 is 9. 9 times 9. Well, it should be obvious. 9 times 6 is less than 9 times 9. Number 12. Roberto wants to make $2 using dollars, half dollars, and quarters. How many different ways can he make $2? Okay, so we're going to use a table on this one as well. Okay, so he's going to have dollars. Let's make sure we have enough space. Dollars, half dollars are 50 cents. And what else does he have? He has quarters, and quarters are 25 cents. Okay, and so his total has to be $2. All right. Wants to make $2 using dollars, half dollars, and quarters. How many different ways can he make $2? Well, he could have $2. Okay, that's one way. He could have $1, right? And then he would need another dollar either with quarters or 50-cent pieces. So if we had two 50-cent pieces, that would be $2. We could have $1 and have one 50 cents, one half dollar, that's $1.50, right? $1.50. And how many quarters would I need to make $2 from $1.50? I would need 2. All right. Could I make $1 just out of quarters? Sure. So we could have $1, no half dollars, and 4 quarters. 4 quarters is $1. So those are all the ways of using a dollar bill. Okay, so now let's move to just half dollars and quarters. So we could have no dollars, and we could have just all half dollars. That would be 4 half dollars. Okay, we could have 3 half dollars. That would be $1.50. And we would have 2 quarters. We could have 2 half dollars. That would be $1, and we'd have to have 4 quarters. $2. Could we have 1 half dollar and the rest be quarters? Yeah, we could. So no dollars, 1 half dollar. We need $1.50 then in quarters. 4 quarters is $1, and 2 quarters is 50 cents. So we would need 6 quarters. All right. Can we make it with just quarters? Can we make $2 with just quarters? Yeah. $4 a quarter. $2 would be 8 quarters. Okay. So how many ways did we come up with? 1, 2, 3, 4, 5, 6, 7, 8. 9 different ways. All right. Let's move on. Page 184. A carpenter builds stools that each have 3 legs each. How many legs does the carpenter use to build 5 stools? Use the array to explain how you know your answer is correct. All right, so stools have 3 legs each. How many legs does he use to build 5 stools? Okay, so 5 stools times 3. Well, I know that 5 times 3 is the same as 3 times 5, and 3 sets of 5 is 15. Okay, so 3 sets of 5. 1, 2, 3. sets of 5. 3 rows of 5 represents 5 stools with 3 legs. So a total of 15. 15 legs. Okay, I don't need all of the squares. This shows 5 times 5. Well, the stools don't have 5 legs. The stools only have 3 legs. I could have also gone 5 stools and had 3 in each stool. So what I'm saying there is I could have also said 5 rows of 3 would have also worked, where each row would be a stool and there's 3 legs on each stool. Either way it works. I just have to have a total of 15. All right, 14. Etta buys some ribbon and cuts it into 7 pieces that are the same length. Each piece is 9 inches long. How long was the ribbon that Etta bought? So 7 pieces. Each of them has to be 9 inches long. So our multiplication problem for that would be 7 pieces times 9. Well, I could do 7 times 10 and take away 7 times 1, because 10 take away 1 is 9. So all I'm doing is making it an easier problem by using subtraction instead, because 7 times 9 is close to 7 times 10. 7 times 10 is 70, and 7 times 1 is 7. So 70 take away 7 is 63. And of course, the easiest way is just to know that 7 times 9 is 63. Okay, so the more facts that you can memorize, the easier these problems become. All right, number 15. Antoine and 3 friends divide some pennies evenly among themselves. Each friend separates his pennies into 3 equal stacks with 5 pennies in each stack. Write a multiplication sentence that shows the total number of pennies. Okay, so first I need to know Antoine and 3 friends. So there's 4 people here. They separate their pennies into 3 equal stacks with 3 pennies in each stack. All right, so we have 3 equal stacks with 5 pennies in each stack. Okay. But there's 4 of them. So we have 4 stacks of 3 times 5. Okay, so Antoine and all 3 friends have 3 stacks of 5. So what would that be? So each friend has 15 pennies. Okay, so 4 sets of 15. 15 plus 15 is 30. So I know the other 2 15s also have to be 30. And 30 plus 30 is 60. So 4 times 3 sets of 5 is 60. Luke is making 4 first aid kits. He wants to put 3 large and 4 small bandages in each kit. How many bandages does he need for the kits? Show your work. Okay, so we know he's making 4 kits. He's going to put 3 large, 4 small in each kit. How many bandages does he need for the kits? Well, let's go ahead and draw our kits. All right, so he's going to have 3 large in each box or each kit, and he's going to have 4 small. How many bandages does he need for the kits? All right, well, I have 7 in this box, in this kit. So there's going to be 7 in this one. So that's 14. 7 in this one. 7 and 14 is 21. 20 plus 7 is 28. So a multiplication problem for our drawing would be 4 sets of 3 plus 4. And 4 times 7 equals 28. All right, number 17. For 17a through 17d, select true or false for each equation. Is 3 times 7 21? Well, I know 2 times 7 is 14. So 3 times 7 would be 1 more 7. 21, yes. 5 times 7 is 28. No. If 3 times 7 is 21, 1 more 7 would put me at 28. That would be 7 times 4, so no. 8 times 7 is 49. I don't think so. 7 times 8, that's the same as 7 times 4 doubled. 7 times 4 is 28. So 28 times 2 is the same as 28 plus 28. That's 56. No. 9 times 7 is 63. Well, actually, we did 9 times 7 on number 14, and we got 63. So, true. Number 18. Circle the number that makes the multiplication sentence true. 10 times what is 40? 4. 4 sets of 10 is 40. 19. For 19a through 19d, select a yes or no to indicate whether the number sentence has the same value as 8 times 6. All right. So 4 times 2 is 8. So is 8 plus 8 the same as 8 times 6? No. 8 times 4 plus 8 times 2. That would be the same because all they did was break the 6 up into 2 smaller numbers. 4 and 2 equals 6. Okay, so that's true. 6 times 4 plus 6 times 2. Well, 4 plus 2 is 6, not 8. So no, that one's not correct. I can break up the 8, but it would have to have a total that adds up to 8. Here, 4 plus 2 is not 8. So they would have had to have 6 times 4 here, or 6 times 6 here. All right, 6 times 4 plus 4. Well, 4 plus 4 is 8, and 8 times 6 is the same, so yes. Number 20. Chloe bought 4 movie tickets. Each ticket cost $6. What was the total cost of the movie tickets? 4 tickets, each $6. What was the total cost? So 4 movie tickets. So we can draw an array to represent that. The 4 rows represent the movie tickets. Each movie ticket costs $6. Okay, so where's my array show? It shows 4 times 6. Again, the easiest way is just to know 4 times 6. All right, so 4 times 6, I can just add these up, right? 6, 12, 18, 24. $24. I could have broken this into 4 times 3 plus 4 times 3 to solve that. 12 plus 12, 24. All right, 21. Write a multiplication sentence using the following numbers and symbols. So we have 6 and 60 and 5 and 2, and we have some parentheses, and we have equal sign. Well, it has to be a multiplication problem. So I know 6 times 10 is 60. 6 times 10 is 60. So there's the 6. I can get 10 by multiplying those two together. And I can put those in parentheses. And the equal goes there. What does it equal? It equals 60. Right, so I use 6, I use 5 and the 2, I use the parentheses, I use the equal sign, and I use 60. All right, so that will work, because 5 times 2 is 10, and 10 times 6 is 60. 22. Lewis started a table showing a multiplication pattern. Complete the table and describe a pattern you see in the products. All right, so he goes 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So we're adding 3's, right? So 12 plus 3 is 15. 15 plus 3 is 18. 18 plus 3 is 21. 21 plus 3 is 24. 24 plus 3 is 27. 27 plus 3 is 30. Describe a pattern you see in the products. Well, there's a couple patterns. One, each product increases by 3 from the previous product. And the products alternate odd, even, right? Odd, even, odd, even, odd, even. Okay. If you multiply 3 times 37, would the product be an even number or an odd number? Use the table to explain your reasoning. Well, let's look at it. We know that 3 times 37 is odd. We know that 3 is odd. So every time we multiply 3 times an odd number, what type of product did we get? 3 times odd, I got an odd answer. 3 times 3, I got an odd answer. 3 times 5, I got an odd answer. So every time I multiply odd and odd, I get an odd answer. So would the product be an even number or an odd number? It's got to be an odd number. In the table, every product in the table, every factor multiplied by 3 that is odd resulted in products that were odd. So in the table, every factor multiplied by 3 that was odd resulted in products that were odd. So 3 times 37 must be odd. All right, 23. Use the number line to show the product of 4 times 8. Well, 4 times 8 means 4 jumps of 8. So if we're at 0, our first jump will be to 8. Then we need to add another jump of 8. 8 plus 8 will put me at 16. 16 plus 8, 1, 2, 3, 4, 5, 6, 7, 8, puts me at 24. 24 plus 8, 1, 2, 3, 4, 5, 6, 7, 8, puts me at 32. So 4 times 8 is 32. All right, so that's it for chapter 4. Practice the different strategies in the chapter. Make sure you're comfortable with them. And I'm confident you'll do well on the chapter 4 test. Our next chapter, chapter 5, we'll be working with multiplication facts some more. So we're using the multiplication facts. So until then, may the numbers always be in your favor.